Hey you guys, this is notes number 7, the quadratic formula, okay? Go ahead and write down the FLT here, and then press play whenever you're ready. All right, so given a quadratic equation, you're going to be able to know how and when to apply the quadratic formula, as well as recalling how to simplify radicals. So there's a few things here that we got to tackle. So just to recall, in the previous lessons, we learned how to solve quadratic equations by factoring, right? And also by completing the square, which led to the deriving of the quadratic formula, right? Okay, so a few things are on the plate here. So we'll take it one step at a time. So we're going to take care of simplifying radicals real quick. So here we go. It's okay if you guys don't remember. It's been a while, and if this is the first time that you guys are seeing this, who cares? Okay, you're going to learn it. So here we go. So when you're simplifying square roots, or in this case we call radicals, okay? I prefer radicals, but it's just a preference, okay? So here we have radical 12, or the square root of 12. Sometimes you get a square root that's not perfect. So what I mean by that is, like, we know that the square root of 100 is 10, because 10 times 10 gives me 100. So we're trying to find a number times itself that'll give you the number on the inside, right? But sometimes, for instance, there's no number times itself, or no integer times itself that'll give you 12, right? So what you do is you have to simplify it. And why we simplify it, you're going to see by the end of today's lesson, okay? So it's not just you doing this for no reason, okay? So what you do here is you want to break down 12, okay? So don't worry if you're not comfortable with your factors. Just take your time. It's not by speed. Just take your time and make sure you're focusing on your craft here, okay? With time, you will get better at it, but that's only when you practice, okay? So what you do is, there are many ways that you could do this. There's a very straightforward way, and the other way is probably more efficient, but you got to be very careful, okay? So here's what I mean by that. The factors of 12 are 3 and 4, or 2 and 6. It really doesn't matter what you guys start out with here, okay? So I'm going to show you. I'll give you a split screen here. Let's say some of you thought it was 2 times 6. And let's say some of you thought it was 3 times 4, okay? What you want to do here is you want to keep breaking these numbers down until you're down to prime numbers, meaning you can't break it down anymore. So for instance, 3 cannot be broken down anymore because the only factors of 3 are 3 and 1. So I'm just going to bring that down. But 4 can be broken down as 2 times 2. Okay? This is all under the square root. All right? So this is the same thing as that. We just factored it. Okay? Now let's say you thought it was 2 and 6. Well, 2 can be brought down as 2 because you can't really break it down. But 6 can be broken down into 2 times 3. So notice how you end up with the same 3 factors on the inside. You have a 3 and 2 2's, okay? So really, here what you're doing is you're looking for a pair. Anytime there's a pair, you can take it out. So here's what I mean. Here I have a pair of 2's. Just think about that there, okay? Really what's happening, and you don't have to write this part down, 2 times 2 is the 4. We know that 4 is a perfect square. So the square root of 4 is really just the 2. And then we leave the radical 3. Okay? That's the logic behind it. Okay? So that's just to show you how this works. But here's what you do. Anytime you have a pair, you take it out. And you tell yourself, what do I have a pair of? Okay? I have a pair of 2's. So a 2 goes on the outside. So that's going to be 2. And what's left on the inside? A radical 3. So this is the simplified version of radical 12. All right. Same thing here. You have a pair of 2's. So a 2 goes on the outside. So I have 2, and I have the radical 3. So I showed you two different ways here. It doesn't matter how you start. You still end up with the same answer. As long as you break everything down, you're fine. Okay? Hopefully that was all right. Let's try another one here. Here's part B. Square root of 18. You could try this on your own if you'd like. Just press pause and then play when you're ready. So here, the square root of 18 is not perfect. So what times what gives me 18? So we could do 9 times 2, 6 times 3. It really doesn't matter. I'm going to do 9 times 2. Okay? Now, I could still break it down some more. I know that 9 is just 3 times 3. And 2 I can't break down, so I'll just bring it down. Okay, do I have any pairs that I can take out? Absolutely. I have a pair of... So think about what goes out there, okay? I have a pair of 3's, so that 3 is going to go out, and I'm going to have 3. What was not circled on the inside of the radical? Just the 2. So 3 radical 2 is the same thing. It's equal to the square root of 18. Hopefully you got that, okay? Okay. Here's part C. Go ahead and try that one there. And press play when you're ready. Okay. So here, I'll show you two different ways. And maybe a way that you should probably avoid, okay? So I know that the square root of, that 48 is not a perfect square, so I'm going to break it down. The factors of 48, 6 times 8, okay? 2 times 24, 4 times 12. There's a bunch here. You can even do 3 times 16, okay? Now, here's the thing. Let's say you're not so great with multiplication, okay? You guys do know that this is an even number. So knowing that it's even, you know that 2 has to go into it, okay? Well, 2 times what gives me 48? Well, if you think about what's half of 48, if you have $48 and then you split it in half, it's 24, okay? You could have easily used 4 times 12 or 3 times 16. It really doesn't matter how you start, so just keep that in mind, okay? Actually, I'll do this 3 ways. Okay, so however you started, it doesn't matter as long as you end the same way. 2 cannot be broken down. 24, one example is going to be 4 times 6, or 2 times 12, or 8 times 3. So you keep breaking it down. 4 can be broken down as 2 times 2. 6 can be broken down as 2 times 3. So here's what I have there. I can't break down 2's and 3's anymore. Okay. Same thing here. This is just 2 times 2. That's just 2 times 6. And I draw arrows so that I don't neglect anything here. Okay. Notice how I still end up with 4 2's and a 3. All right. Now here, same thing. Okay. Some of you may find this redundant already, and I'll address that in 1 second, okay? First, let's get the answer, okay? I'm going to circle my pairs, okay? Pairs come in 2's, all right? So I actually have 2 different pairs here. So I have a pair of 2's here, and I have another pair of 2's there. So 2, the orange 2 times the other orange 2 is a 4. All that's left on the inside that wasn't circled is that 3, so 4 radical 3, all right? Okay, and then we get the same thing. But here's what I notice is the number one mistake that people make. they think they found a shortcut. So they think, wait a minute, okay, I know the square root of 4. The square root of 4 is 2, so that's just 2 the square root of 12. Okay, the issue with that is if you don't pull out the largest perfect square, you're not going to get the right answer. So this right here is a simplified version, but it's not in the simplest form. 12 can still be broken down into 2 times 2 times 3. So you neglected a pair that you could also take out. Now, if you're really good with your multiplication, if you think about your largest perfect square, in this case, like 16, 16 is the largest perfect square factor. So then the square root of 16 is 4, and you're left with a 3. That's if you're really good with multiplication. But again, go with where you're at, okay? Don't try to rush your process here, okay? If you're not good with multiplication, take your time. If you are good with multiplication, you could probably skip a few steps. Okay? So, here's one more. Pause and play whenever you're ready. Okay, so here, 120 is a large number. I noticed that it's even, so I could probably put a factor of 2. But I noticed that it ends in a 0, so I know it's divisible by 10. So 10 times 12 will give me 120. Okay? And again, if that's not what you were thinking, it's not a problem because at the very end, you should have the same factors, okay? I know 10 can be broken down as 2 times 5. 12 can be broken down as 2 times 6. But now 6 can also be broken down as 2 times 3. All right. And remember, with multiplication, order doesn't matter, so you could rearrange this as much as you want. I like to group all of them together, so 2 times 2 times 2 times 3 times 5, but it's really not necessary here, okay? So again, we're looking for a pair. I have a pair of what, right? I have a pair of 2s, so a 2 is going to go on the outside. What's not left on the inside? I have a 2, a 3, and a 5, right? They don't have any pairs, so they're going to be left inside the radical. So I'll just simplify that. 2 times 3 is 6, times the 5 is 30. So this is the best that we can do in terms of simplifying the square root of 120. All right? Okay. Let's keep going. Square root of 39. Pause and play when you're ready. 39, it's not even, so I know 2 doesn't go into it, but if you add your digits, 3 plus 9, if you remember this trick, 3 plus 9 is 12, and I know 3 goes into 12, so I know it's going to be divisible by 3, all right? So if you ever get a large number, some things to look for is it even? If it's even, you know it has to be divisible by 2. If it ends in a 0, you know you could probably divide by 5 or by 10. And if you add up all the digits, that sum, if it's divisible by 3, then you know the whole thing is divisible by 3, if that made sense, okay? So here in my mind, what I'm doing is 3 goes into 39. Okay, so that's once. Okay, so 3 times 13, right? Okay, so here's the issue. I can't break down 3, because 3 times 1 is 3. And I don't care about ones, because ones don't really help us. Now 13, is there anything that multiplies out to 13? So if you notice, there's really nothing else that multiplies out to 13. So you factored this as far as you could, all right? Now, are there any pairs? If you notice, there are no pairs. There's no pair of 3s. There's no pair of 13s. So what the heck, right? So this tells us that it's simplified as much as possible, so we're just going to leave it there. Sometimes you just can't simplify it. It's already in simplest form, okay? All right, and here's the last one, just in case we forgot. The square root of 64. Square root of 64 is a perfect square, if you guys don't remember. But even if you break it down, it still works the same way. The square root of 64 is 8, because 8 times 8 is 64. Now, if you broke it down, I don't know, 2 times 32, 2 times 2 times 16, 2 times 2 times 4 times 4. Okay, you could break it down even some more, but I have perfect pairs here. I have a pair of 4s, so I'm going to put a 4 on the outside. And then I have a pair of 2s here. So I'm going to bring the 2 out. If you notice, everything on the inside was highlighted. Anytime you highlight everything on the inside, you know it's going to be a perfect square. 2 times 4 is just that 8. Okay? So if you need a little cheat sheet, some common perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144. That's about as far as you probably need to go. Those are all of your perfect squares. So, okay, so we know how to simplify radicals. We took care of that. Boom. So now let's jump into the quadratic formula. I'll focus first on the how, and then I'll start focusing on the when, all right? All right, so recall, all right? Remember, so that if we let ax squared plus bx plus c equals 0, assuming that a is not 0, okay? So if we have any quadratic equation that's equal to 0, we can apply the quadratic formula, which is x equals negative b plus or minus square root b squared minus 4ac all over 2a. There's a neat little song if you want to YouTube it. It's catchy. There are many songs out there, but if you want it to stick in your head, go ahead and look that up, okay? So, some things to keep in mind. A, B, and C are just numbers. They call those parameters, okay? A, B, and C are just numbers. So the A value is the number in front of the x squared. So whatever is in front of the x squared is your A value. Whatever is in front of your linear term, your x, is going to be your B value. And whatever that doesn't have an x next to it, we call that the constant, will be your C, all right? And this is all assuming that your quadratic equation is equal to 0. Keep that in mind, all right? So you guys have the quadratic formula here. And again, you want to refer back to it as much as you need to until you remember it, all right? So let's try it out. Here's example 2. Go write it down. Press play whenever you're ready. We want to solve for x here. Sometimes they'll have the instructions, solve for x or solve the equation or find all x for real solutions, solve the roots. There are many different ways, and I'll show you guys all the different ways that they could possibly ask you, okay? So here we go. First thing you want to note is your quadratic equation equal to 0? It is. So we don't have to move anything around. Everything is perfectly fit here. And actually everything is in order. So now we know that A is 2. I know that B is a positive 7. And I know that C is a positive 3. 2 is also positive. I'll put it there. And I'll tell you guys why I focus on that in a second. All right? So now that we have A, B, and C, we write out our quadratic formula in general so that we remember it. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. Okay, so here we go. X equals. Here's what I do so that I don't confuse myself. Every time I have a, excuse me, a parameter or a letter, I'll put parentheses there first. So I have x equals negative b plus or minus square root. b squared minus 4ac all over 2a. If you're the type that tends to mix up their signs, this is perfect for you guys. All right? So here we go. X equals negative b. Well, what's b? I know b is 7. All right? Plus or minus square root of b squared minus 4ac all over 2a. If you color coordinate, it's really tough to mess up. All right? Okay, that's probably the toughest part. The rest is just making it look a little bit easier. So here we go. So now we're going to have x equals, well, obviously, we'll take care of the easy parts. Like down below, 2 times 2 is really just 4. The negative times the 7 here is just negative 7 plus or minus the square root. I know that, I took care of this already. I know that 7 squared is 7 times 7, which is 49. And I know that 4 times 2 is 8. Times 3 is 24. And there's a minus sign there, so minus 24. All right. And I keep going. Now I work on everything inside of that radical. So notice how I took care of all the easy parts first. Okay, now I take care of this. Well, what's 49 minus 24? 49 minus 24 is just 25. Okay, so now we ask ourselves, okay, can I square root that? Is 25 a perfect square? Okay, and it is. The square root of 25, a number times itself, that'll give me 25, is 5. So what you do is, first, let me take care of the easy part. Negative 7 plus or minus. Okay. And again, color coordinating really helps here. The square root of 25 is 5. All right. Once you square root, the square root goes away. Okay. Now, if you can't square root it, it stays there. All right. So this right here is kind of like completing the square now, where you would split your two equations. So x will equal negative 7. Let me write this out real quick so you guys can see it. So there's a plus or a minus, if you guys see right there. So you actually have to split that. One has to be a plus and one has to be a minus. Okay? Okay, so here we go. This came out nice. Negative 7 plus 5. Different signs we subtract, so that's negative 2 over 4. Negative 2 over 4 is a fraction, but I can reduce that to negative 1 over 2 if I just divide top and bottom by 2. Replay this as much as you guys need to, okay? Go at your own pace. Don't feel like you have to rush it, all right? So we have one solution here. Negative 7 minus 5, same signs we add, so that's negative 12 over 4. 4 could actually go into 12, so that's actually x equals negative 3. Here's your second solution. So here we have one solution, two solutions. All right, and that's it. So here's the thing. That's a lengthy process, right? Was there an easier way? Okay, absolutely. So you guys are learning two things today, okay? You're learning how to use it, but you also want to keep in the back of your mind, am I being efficient? It's way easier here to factor this. Okay, 2x and x, if you guys remember. And then you keep guessing and checking until you have what you want. I'm going to guess that. Let me check my outer. My outer is 6x. My inner is 1x. And that gives me exactly what I want. The 7x right here, okay? So if I factor it, I could just use the zero product property. 2x plus 1 equals 0. X plus 3 equals 0 here. Eventually, you'll get negative 1/2 and negative 3, which is exactly what we got here. All right? Okay, so what the heck, right? Which one's easier? Obviously, factoring here is a lot easier, right? So why would we ever use the quadratic formula? So what you guys have to keep in mind is, are all quadratic equations factorable? Okay? Sometimes your quadratic equations are not factorable. Okay? If it is factorable, then you factor it. That's probably the fastest way. Now, if you can't factor it, then you resort to the quadratic formula. Knowing that the quadratic formula takes a long time, you only want to use it when you absolutely need to. Okay? You could go all day with the quadratic formula for any quadratic equation, but you would be wasting your time, right? So the thing with math is you want to be as efficient as possible whenever you can. Okay? So, let's try another one. Here's part B. Okay? So, what do you notice right away? Okay, what's different about this problem than the previous problem here, okay? So, hopefully you notice that the right-hand side is not 0. In order to use the quadratic formula, you have to make the right side 0. So, what we got to do first is we have to clean this up a little bit. We have to move this 5x over. I notice that that 5x is positive, so to move it over, I'll just go opposite. Subtract 5x. Now, where would you guys subtract 5x on the other side? You would subtract it where you could actually combine it. I can only combine 5x here, so that's where I'm going to place it. All right? Okay, so now 5x minus 5x is 0. That's exactly what we want. We have 25x squared. 15x minus 5x is 10x. All right? Now, here, factoring is easier. But for the sake of you guys knowing how the quadratic formula works, I want you guys to go ahead and use the quadratic formula here, okay? Pause and press play whenever you're done. Okay, so here we go. We now know that A is 25. B is a positive 10. C is a positive 1. All right, so x equals negative b plus or minus square root b squared minus 4ac all over 2a. So x equals negative, I'm going to put in my placeholders, negative b plus or minus square root of b squared minus 4ac all over 2a. Again, if you do this, you really can't mess up, all right? So b goes in here, so I'll put a 10. B goes in there, 10. A goes in here, C goes in here, and A goes at the bottom. All right? All right, let's keep going. X equals, down below, 25 is a quarter. 2 quarters will give you 50. Okay, a negative times 10 is just negative 10. And then there's your square root, okay? So I know that 10 squared is just 100, okay? 4 times 25, so 4 quarters should give you 100, right? 4 times 25 is 100, times 1 is 100 as well. So we have minus 100 there, okay? 100 minus 100 is 0. Okay, so here's the thing. What's the square root of 0, right? What number times itself will give you 0? Pretty easy. That's just 0. Okay, so you're left with this. You're left with x equals negative 10 plus 0 over 50, or x equals negative 10 minus 0 over 50. Well, it doesn't matter if you add or subtract 0, right? You're just going to get the same thing. So you're just going to get negative 10 over 50 here. And coincidentally, you'll also get negative 10 over 50 here. Okay? This answer could definitely be reduced if you divide top and bottom by 10. You should get negative 1 over 5, negative 1 over 5. Now, in the case that your solutions are the same, you only need to write it out once, okay? So especially on delta math, so let's say you're solving this out and you find out that your two solutions are the same, all you would write is x equals negative 1/2. Sorry, negative 1/5, okay? No need to write it out twice, all right? And again, this one's way easier to factor. This is just 5x plus 1, 5x plus 1 equals 0. Okay, and you can confirm that if you guys like. And then once you solve for each, you should get negative 1/5 as well. All right. So let's talk about efficiency again. Would you ever use a quadratic formula? Always, right? So the first thing you need to do in the back of your mind is, can I factor it? And if you can't factor it, then you resort to the quadratic formula. So going back to the very beginning, you guys, that is your when, okay? This is your when right now, okay? So I'll say it one more time so you can write it down. You only use the quadratic formula if you can't factor it, okay? So seeing as how this is the quadratic formula lesson, I'll focus on equations where you can't factor it, okay? Okay, so here we go. Here's part C. Here's one for you guys to try again. Press play when you're ready because I'm going to move a little bit faster. So pause and try it out on your own first. Okay, so here I want to make sure that my right side is 0. So I have to move this 3x squared by going opposite or the inverse. And since it's an x squared, I would probably add it right here to the other x squares. Now my right side is going to be 0. 9x squared plus 3x squared is 12x squared minus the 11x that I bring down plus the 2. Okay. Now that it looks just like how I want it, the right side is 0 here, right? And I have a quadratic equation. I know that a is 12. I know that b is negative 11. And I know that c is 2, positive. Okay. So here we go. I have x equals negative b plus or minus square root b squared minus 4ac all over 2a. Now, if you wanted to write out the formula, you can, okay? So you go at your own speed. You know yourself best in terms of your comfort levels, okay? Let's plug in what we know. X equals negative b, so that's negative 11. Negative 11 squared, 4ac all over 2a. Okay, now if you don't put in the parentheses, people tend to get it wrong because of the negatives. They lose track of what the negatives are doing, okay? So here we go, x equals. Down below in the denominator, 2 times 12 is just 24. Up top here, a negative times a negative 11 is a positive 11. All right, plus or minus, square root. Negative 11 squared, okay, is negative 11 times negative 11, all right, which is 121. Just remember, when you guys square a number, it always comes out positive, all right? So this is positive 121. 4 times 12 is 48, times 2 is 96. Again, you don't have to go at my speed, all right? Just go as much as you need to go, and eventually with practice, you will speed up as well, all right? Okay, so now we have 121 minus 96. Oh gosh, what does that come out to? That's going to be positive 11 plus or minus 24, the square root of, let's see, 121 minus the 96. Okay, I'm going to borrow. So 11 minus 6 is 5, and then 11 minus 9 is 2. So that's 25. All right. Cool. So the square root of 25, that's perfect. The square root of 25 is just what, right? Is just 5. We don't write the square root of 5, okay, because we took the square root. So now we split it into two equations. X equals 11 plus 5 over 24, and x equals 11 minus 5 over 24. That's going to come out to 16 over 24, and this is going to come out to 6 over 24. But if you reduce both of those there, so for instance, the first part, if you divide top and bottom by 8, you should get 2 over 3. And at the bottom, if you divide top and bottom by 6, you should get 1 over 4. All right. Okay. So I'm going to give you guys a little hint here. All right. This square root, okay? Anytime your square root comes out perfect, that tells you that you probably could have factored that. I'll say that one more time, okay? If your square root comes out perfect, okay, where you can square root it, that meant that it was easier to factor. Okay? So just keep that in mind. You won't know until you try to factor, right? But again, I'm just focusing on the quadratic formula, so let's move on. Okay, here's the last example. Example 3, find all real solutions in simplest form. Pause, write it down, press play when you're ready, okay? Okay, so here I noticed that it's already equal to 0, so I don't have to move anything around. So let's write it down. I know my A is 4, right? I know my B is negative 5, and I know my C is negative 4. Watch out for your signs, okay? X equals negative B plus or minus square root B squared minus 4AC all over 2A. If you're putting parentheses, it's really tough to make a mistake. X equals, there's your negative B, there's your negative B again, your A, your C, and your A one more time, okay? All I did was I plugged in A, B, and C. All right, so starting with that bottom part, 2 times 4 is just 8. Negative times a negative 5 is just a positive 5. And then we deal with the square root. So the majority of your work is going to be inside that square root, okay? Negative 5 squared, so negative 5 times negative 5 is just positive 25. Okay? Now, very carefully, negative 4 times 4 is negative 16. Negative 16 times another negative 4 gives you a positive 64. Watch out for your signs. All right? Let's keep going. X equals 5 plus or minus the square root of something all over 8. Okay? Well, 25 and 64 makes, what is that, 89? Okay. Okay, is 89 a perfect square? Is there a number times itself that'll give me 89? I don't think so. It's not a perfect square here. So that tells me, before I continue, that tells me that there's no way that I could have factored this. Not factorable. There was no way that I could have factored it. Because I noticed that I don't have a perfect square. All right? So what's left is, you got to see if you could simplify this. So this is why I taught you guys simplifying. Now, is there any number that multiplies to 89? Okay, so let me run through my list here. I usually check for 2, 3, 5, and 10. So obviously, just a quick recap, if it ends in 0, you know it's divisible by 10. For 5, if it ends in a 5 or a 0, you know it's divisible by 5. Now, if it's even, if it ends in an even number, you know it's divisible by 2. And if you take the sum of the digits In this case, 8 plus 9 is 17, right? 3 has to go into 17 if you want to divide it, but 3 doesn't go into 17 here. So this is all running in my mind, and it will with you too, okay? 89 is not even, so I know I can't divide it by 2. It doesn't end in a 5 or a 0, okay? So the last thing to check for is the 3. 8 plus 9 is 17. Does 3 go on a 17 perfectly? It doesn't. So that probably means that I can't break down 89, meaning that I can't simplify it. So I leave it as so, okay? So I have two solutions here. I have 5 plus the square root of 89 all over 8, and x equals 5 minus the square root of 89 all over 8, okay? So keep in mind we have two solutions, but here's the thing. You can keep your answer like this. You just have to use the plus or minus symbol, all right? So on Delta Math, they give you that option, so just keep that in mind. All right, let's do another one. Pause and play whenever you're ready. Try this one out. Okay, so I notice the right-hand side is not 0, so I'm going to bring that guy over, and I'm going to subtract it where it can be combined. So I have 0 here, 5x squared minus 10x plus 4. All right, so A is 5, B is negative 10, and C is a positive 4. All right, here we go. X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. Let's plug in my values. I know that x equals negative b, so b is negative 10. B occurs here as well, 4ac all over 2a. Again, if you're stenciling it in, you can't make a mistake. It's really tough to. Okay, down below, 2 times 5 is just 10. Up top here, negative times a negative 10 is a positive 10, plus or minus. Negative 10 squared. Remember, when you're squaring a value, it's always positive. 10 squared is just 100. Okay. 4 times 5 is 20. And 20 times 4 is 8. So I have minus, sorry, did I say 8? I meant 80. So minus 80. All right. All right, here we go. X equals 10 plus or minus the square root of something all over 10. 100 minus 80, very easy, that's just 20. Now, is the square root of 20 a perfect square? Absolutely not, right? There's no number times itself that'll give me 20. So the last thing I check for is, can I simplify this? So sidebar, here we go. Square root of 20. Factors of 20 are 4 times 5 or 2 times 10. And I'm going to keep breaking it down until I can't break it down anymore. Okay. Do I have any pairs? I do. What am I going to take out? I have a pair of 2's. So this right here is 2 radical 5. So here's what's going to happen. X equals 10 plus or minus something all over 10. The square root of 20 is the same thing as 2 radical 5. All right? Now the last part. Okay? Everything that I highlighted, the 10 and the 2 in the numerator and the 10 in the denominator, do they all have something in common so that I can reduce this fraction, right? You notice that I could divide all those numbers by 2. So, very carefully, if I divide the first 10 by 2, I will get 5. If I divide that red 2 by 2, I get 1. Okay? If I divide that bottom 10 by 2, I get 5. Think of this as you guys reducing the fraction, okay? The radical stays the same. Now, if there's a 1 in front of the radical, you really don't need it. So technically, you could just write it as x equals 5 plus or minus radical 5 all over 5 without that little 1 right there. So there you have it. Okay? So sometimes you can simplify it and sometimes you can't. All right? I think I have... okay, last one. Well, last one. Here we go. Try this one out. Press play when you're ready. Okay, right hand side is not 0, so I'm going to go ahead and subtract x here, subtract x here. Remember, x is just a 1 in the front. If that confuses you. Right hand side is going to be 0, so here I have x squared plus 2x minus 7. Okay, so what's my a? Okay, what's the number in front of that x squared? It's that invisible 1. Okay, b is a positive 2, and c is a negative 7. All right, here we go. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Color coordinate if you guys can. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. All right. X equals, down below, 2 times 1 is just 2. Negative times 2 is a negative 2, plus or minus. 2 squared is 4. 4 times 1 times 7 is 28. Okay. Now, x equals negative 2 plus or minus the square root of something all over 2. 4 minus 28 are different signs, so we subtract. 4 minus 28 is 24, but we keep the sign of the larger number, so this is going to be negative 24. Okay, so the thing is, this is a big no-no with real numbers, okay? When you square root, okay, you're thinking of a number times itself. That'll give you the number on the inside. But if you multiply any number times itself, it'll never give you a negative number. So if you're ever square rooting a negative number, right away you can say dot, dot, dot. It's kind of like a triangle here. That means therefore. So therefore is kind of like in conclusion, no real solutions. Make sure you guys say real. I'll focus why later, but for now, no real solutions, okay? If at any time you run into a square root with a negative on the inside, you can then conclude that there are no solutions, no real solutions, okay? And that's it. Okay, here's one more. Wait, hang on. Did I miss something? Oh, I did miss something. Ah, see, even Mr. Lee makes mistakes. Here we go. I did make a mistake. And hopefully you guys caught it. C is negative 7. I put 7 in there. That changes everything. Okay? So here we have 2 squared, which is 4. Negative 4 times 1 times negative 7 is a positive 28. I thought that looked a little bit funny. Okay? 4 plus 28 is 32. So I guess we will have solutions here. All right? Okay. Definitely not a perfect square root, but can I simplify it? So here we go. Square root of 32 is 16 times 2. 4 times 4 times 2. 2 times 2 times 2 times 2 times 2. All right? If you find your shortcuts, you find your shortcuts. Doesn't matter, okay? I have a pair of 2's here, and I have another pair of 2's here. So I have in total 4 radical 2 left over. So x equals negative 2 plus or minus 4 radical 2. This looks a lot better. Okay, 4 radical 2. Now I look at my 3 digits here, negative 2, positive 4, and the 2 at the bottom. We don't look at the square roots, okay? Is there a number that they have in common that we could divide all of them by? Absolutely. We could divide all of those by 2. So x will equal negative 1 plus or minus 2. The radical 2 stays the same. And down below, 2 divided by 2 is just 1. Okay? Now, when you're dividing by 1, it really doesn't change anything. So you could just write negative 1 plus or minus 2 radical 2. All right? Okay. I think that was my first mistake. All right, last one. Press play when you're ready. Okay, try this one out. A is 2. B is that invisible 1 right there. C is 6. Okay, so x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I know that b goes here, a goes here, c goes here, a goes here. X equals negative 1 plus or minus. Down below I have a 4. Inside the square root or the radical I have 1 squared, which is 1. 4 times 2 is 8, times 6 is 48, so 1 minus 48. I notice right away that I'm square rooting a negative 47, which is a red flag here. You can't square root negatives for now, so therefore, no real solutions. And that's it. Okay, so sometimes you will run into the square root of a negative. Now, what does it really mean with no real solutions? We're going to get into that soon, very soon, okay? So you guys are just learning your analytical skills here. You're learning how to do your algebra, all right? But go ahead and practice on Delta Math. Text me if you guys have questions, okay?